morning students once again, and we are continuing with our chapter periodic classification of elements. So far we have seen Mendeleev Dobryna's triads classification as well as the Newland's law of octaves. Now let us just move ahead and we shall learn about the Mendeleev's periodic table. So before actually going into it, we need to understand what is the actual meaning of a periodic table. What is a periodic table? It's nothing but it's like a chart, okay, showing different elements which are arranged or classified under different groups based on their similar properties. All the similar properties were kept under the same group. So that is called as a periodic table actually. So even Mendeleev also has taken the atomic masses into consideration, and he stated that the properties of elements is nothing but it is a periodic function. That means there is a repetition of the similarities of the elements based on their atomic masses. That means the properties of elements is a periodic function of their atomic masses. When you arrange the elements in an increasing order of the atomic masses, you will find that there will be a periodic repetition, nothing but a periodic at regular intervals you will find a similar elements having similar properties. There will be some similarity in the properties of elements once they are arranged in the increasing order of atomic masses. Okay, so here he just not only took atomic masses into consideration but also found out the similarities in the chemical properties. That means how different atoms are combining. What is the similarity between different elements combining with other elements? How are they able to combine with the chemical properties? How are they involved in various chemical reactions? That also he considered. So he took into consideration mainly two things actually, the reaction with hydrogen and the reaction with oxygen, children, because both are very active elements, and if you get to know how different elements combine with oxygen and hydrogen, you will know the other similar. You can actually predict the chemical properties of those elements and you can know the similarities also. So what he took these two as the reference actually, as a reference to know whether these two elements are similar or not. Because if they are similar, they will form oxides, they will react with oxygen and form oxides in a similar manner, and they will react with hydrogen also and they form hydrides also in a similar manner. So you can see that here if you see in the Mendeleev's periodic table, he took into consideration not only the atomic masses, like in increasing order of atomic masses he distributed all the elements. The then known 63 elements were actually classified by Mendeleev. Okay, and not only that, but he took into consideration their chemical properties similarities also, similarities in the chemical properties with reference to oxygen and hydrogen. Here he saw that different oxides, they were given a general formula like R2O. This is an oxide. R means it's the any element you can substitute in place of R. So say for example, if it is lithium, it is Li2O, lithium oxide. Sodium oxide, like that, potassium oxide. So general formula, in place of lithium, sodium and K, if you write R, the general formula becomes R2O. In the similar manner, hydrides, if they react with hydrogen, they form a general formula, hydrides they form, and the general formula can be written as RH. So in that manner, this is like LiH, lithium hydride, sodium hydride. So instead of these, a general formula is given. So if you see the Mendeleev periodic table, he has classified different elements in this manner. You see that there are 8 groups, the vertical columns, okay, the vertical columns, they are called as groups, okay, these are the groups, and periods, the horizontal rows, they are called as the periods. Okay, I can say like that also. So the periods are the horizontal groups, horizontal rows, and the groups are nothing but the vertical columns. So how many groups are there in Mendeleev's periodic table? We have 8 groups, 8 groups. and such that the elements are classified or sorted in such a way, that all the members in a single group have similar properties. All the members, say take for example in group 1, all the members in group 1 will have similar properties. And how we come to know about it? By the way they react with oxygen and hydrogen. All of them react with oxygen and hydrogen in a similar manner, and they form oxides and hydrides with the same general formula. So you can understand now that all of these have similar chemical properties. You can predict if oxides and hydrides have similarities, they will react with other elements also in a similar manner. So here 8 groups are there. If you talk about periods also, actually in the original model, in the original periodic table, you have 7 periods, but here in your textbook only 6 periods are given. So we'll be talking about, till calcium we will be learning more. Till calcium only we'll be stressing a lot. So other elements I have not written for that purpose. Okay, till calcium, if you remember, that's more than enough. Okay, so you can see that each group has one special or specific general formula for hydrides and one formula for oxygen. Like if you see beryllium, it is RO, it is not R2. That means it is different. Beryllium is 100%, like it is definitely different from that of lithium. That's why it is kept in a separate group. Did you get that? Beryllium reacts with oxygen to form like RO. The general formula is RO. Magnesium, if you see, MgO, isn't it? So Mg, instead of Mg you write R, which is RO. In the similar manner it forms hydride with the general formula RH2. So all these elements like the calcium and the magnesium, all these they have similar properties, and that's why they are kept in this group.